Here are a few examples of the Pythagorean theorem. In example 1, we're going to find x. We're going to do that by using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. The first thing we must do is identify which sides are a, b, and c. C is always your hypotenuse, the side across from that right angle. So I'm going to label that C. A and B, it does not matter. So I'm going to label side 2 as A and side 5 as B. So now we can substitute those values into our equation. So we have 2 squared plus 5 squared is equal to x squared. We can simplify and say, well, 2 squared is 4, 5 squared is 25. And simplify again, we can combine like terms. 4 plus 25 is 29. Now here's where we may want to use a calculator. So on your Inspire, I want you to choose a new document, number 1. If it asks you to save, we just say no, and add a calculator page. And what we want to do is take the square root of both sides, because x squared, to undo that squared, we say the square root. So I'm going to say control squared to get that square root, and 29. And we get a decimal here, and I'm going to approximate to 1 decimal place, to a 1/10th place. And notice we have 5.38. That 8 will round that 3 up, so we will say that x is approximately 5.4. Example 2. Again, find x. Let's start with that Pythagorean theorem. A squared plus b squared is equal to c squared. And again, let's identify the sides of our triangle. Well, we know that side C is the hypotenuse. And in this figure, 9 is the length of our hypotenuse. So I'm going to label that with a C. A and B, it does not matter. So I'm going to choose side length 4 for A and side length X for B. So let's substitute those variables into our equation. So now I have 4 squared plus X squared is equal to 9 squared. Well, 4 squared is 16 and 9 squared is 81. So I can simplify and say 16 plus x squared is equal to 81. Now we want to get x by itself. So what we want to do is move that 16. So the inverse of 16 is to subtract 16 from both sides. So now we can say that x squared is equal to 65. And again, we're going to take the square root. So I'm going to use my calculator, and I'm going to take the square root of 65. And again, I get a decimal, and here I have 8.06, and that 6, if we round this to 1 decimal place, that 6 will round that up to 8.1. Example 3. Here we have 13x and 5 as our side lengths. We'll use that Pythagorean theorem yet again. Identify all 3 sides of your triangle. I know that C will always be the hypotenuse. A and B are the 2 legs. In this figure, the hypotenuse is 13, that side across from the right angle. A and B, I'm going to say A is side X, B is side length 5. So I'm going to substitute those into my equation. So we have x squared plus 5 squared is equal to 13 squared. Now 5 squared is 25, 13 squared. If you're not sure, you can always use your calculator. Like here, if I say 5 squared is 25, 13 squared is 169. So we can replace those in our equation. So I have x squared plus 25 is equal to 169. Again, to get x by itself, we're going to subtract that constant. So subtract 25 from both sides of our equation. So we'll have x squared is equal to 144. And to get x by itself, because the inverse of x squared is the square root, control x squared to get that square root of 144 is 12. So here x is equal to 12. Now in the first 2 examples, we had decimals as answers. In this third example, we had a whole number. We have 12. That happens in special cases, and those special cases are called Pythagorean triples. So on your notes, you have a table with these Pythagorean triples. So let's talk about the first one, 3, 4, 5. This is the most common Pythagorean triple. Another of this 3, 4, 5 is 6, 8, 10. Because if you multiply each of the sides by 2, you get 6, 8, and 10. And each of these, if we assign A, B, and C to the values, you'll have A squared plus B squared is equal to C squared every time. We have, if we multiply all the sides by 3, we have 9, 12, 15, and this happens for any value that we multiply all 3 sides by. The same for 5, 12, 13. If I increase all of those sides by 2 times, so we get 10, 24, 26, 15, 36, 39. And again, we can multiply these 3 values by any number. So I can replace that with 5x, 12x, and 13x. 8, 15, and 17. If we multiply all 3 of those sides by 2, we get 16, 30, 34. That's a Pythagorean triple. 24, 45, 51 is that triple multiplied by 3. And of course, 8x, 15x, 17x, any value we put in for x would also be a Pythagorean triple. 7, 24, 25. That one's a 14, 48, 50. A 21, 72, 75. Triangle. Again, if we multiply those by any value for x, we would still have that triple. There are many more triples than just these 4. These are the 4 most commonly seen. And if you see and recognize any of these, you can easily find that missing side length by recognizing that triple.